This is the 7th robotic lecture of CAM 810S. The topic is safety in robot cells. Before analyzing the specific aspects of safety around robots, we're going to look into some general aspects of safety. Because safety is extremely important, it is often written in capital letters. But just as often, the true meaning of safety is carelessly ignored, as this cartoon illustrates very nicely. In daily life, we are surrounded by hazards. According to Wikipedia, a hazard is a situation that poses a level of threat to life, health, property, or environment. A risk is the likelihood that persons may be harmed when exposed to a hazard. In order to obtain a satisfactory safety level, we have to assess, to analyze, and manage risks. A good help to remember the steps to be taken is the word safer. S for see it, that is to identify hazards. A for assess it, that means assessing the risks. F for fix it, which means taking action by implementing safety measures. E for evaluate it, that is checking or verifying that the safety measures are effective. And R for review it, that means analyzing and checking the situation again and again. The following cartoons illustrate the first 3 steps quite nicely. The big stone at the edge of the steep hill poses a tremendous hazard. But hazard and risks must first be perceived or realized. The risk must then be assessed or analyzed. And proper action must be taken. In this case, of course, before the stone falls. All the time we hear and read the sentence, an accident has happened. But is this correct? Do accidents just happen? Look at this fellow. Driving nails into a plank, he misses the nail, strikes his finger, and blames the hammer. This accident did not happen. It was caused by the fellow's carelessness. Accidents are caused. They do not just happen. Remember the 2 kids on the motorbike. Conclusion: safety starts with an S, but it begins with you. You and I, all of us, are responsible for our safety. The most sophisticated safety measures and devices are useless if we ignore them. Here are a few important measures for personal safety in workshops and laboratories. Do not wear loose clothing. No loose ends or shirt sleeves. No rings and watches. No loose hair. wear solid shoes, and use personal protective equipment, PPE. Here are a few quite important items of personal protective equipment or PPE. Starting at 10 o'clock and going clockwise, we see, starting at 1 o'clock, of course, at 1 o'clock, we see goggles and shield to protect our eyes, respirators for our respiratory system, gloves to protect the hands in some cases, not always, good solid footwear for the feet, aprons for welding, for instance, and ear protection for noisy environment. And now to safety in conventional industrial robotic cells. There are two basic safety rules for robotic cells. When a person enters the hazardous zone, robots, machines, and equipment must stop immediately. And as long as a person stays in the hazardous zone, it must be impossible to activate the robots, machines, or equipment from outside the cell. This robotic cell is surrounded by a safety fence. And starting at 11 o'clock, we see a number of other safety devices. A door at the backside of the cell, through which the cell can be accessed. This door is monitored by a micro switch. Next device is a light curtain, which is going to be explained later on, as is the case for all following devices. Next is a two-hand control, then a front door, which is monitored by a magnetic door switch, a laser scanner, then an access control scanner, an enabling switch, and a muting sensor. And finally, a safety shutdown mat and an emergency off button. Safety fences are a simple and effective way to protect personnel from the dangers posed by automated equipment. They are composed of wire mesh panels framed in steel angles, fixed to the floor. Access is granted by sliding or hinged, but always monitored doors. Safety or shutdown mats are composed of strips of switch elements embedded in a rubber mat. If a person steps on the yellow mats, the robot stops immediately. Light curtains are an elegant solution if good visibility is required. They are composed of several one-way photoelectric sensors. When the light beams are interrupted, a signal is triggered and the robot stops. Light curtains can be arranged either vertically or horizontally. An economic solution is to deviate the light curtain the beams with mirrors situated in the two front posts. There is a good YouTube video on this. This cell combines safety fences, the backside and in front, vertical and horizontal light curtains. Whereas this cell provides safety on three sides with light curtains deviated by mirrors. Doors are monitored by microswitches. I've studied already in the previous lecture. Or magnetic door switches. Teach pendants are equipped with an emergency off button. And handheld permission switches may be used for light curtain muting and other muting procedures. For setup operations, maintenance and repair, robotic cells must temporarily be accessible for operators. The cell is divided into three zones. Cam-controlled microswitches at the base of the robot limit the rotation range of axis 1 so that zone 1 and 2 may temporarily be accessed by an operator. Muting procedures must be designed in such a way that operators are never at risk. Instead of safety fences, laser scanners combined with a specific software may restrict access to robotic cells. This cell is divided into three safety zones: a blue one, a yellow one, and an orange one. Here are two examples of safety laser scanner applications. If the operator enters the warning zone, an acoustic alarm is sounded and a flashlight warns the person. When the operator enters the protection zone, all movements must be stopped immediately. This cell is also divided into a warning and a protection zone, and additionally into a left and a right side. When the robot is operating on the right side of the cell, access on the left side is permitted in both zones. On the right side, access is only possible in the warning zone. If the robot operates on the left side, access rights are reversed. In newer robot systems, a combination of sensor technology and software permits access to the robot cell while the robot arm is in movement. When the operator enters the cell, the robot arm slows down to a safe speed, usually not higher than 250 millimeters per second. Another possibility is the limitation of the arm's working envelope, so that the operator is also out of danger when entering the cell. Some robots of the newest generation have become smart and safe enough to collaborate with people. This is known as HRC, human robotic or human robot collaboration. This robot works alongside human workers without any safety devices in a BMW car door assembly line in the United States. Find out more about this newest and interesting trend in industrial robotics with the instructions on worksheet 27. This is the end of the 7th robotic lecture of CAM 810S. Please watch the proposed YouTube videos and do your exercises on safety in robot cells. Thank you for your attention.